Okay, this video is for simple setup of Cmyk, and this video will just be the computer portion. There will be a companion part 2 video that will show how to use the printer, the Epson, to print out your films. So this video will just cover how to set up your image to get ready to print. So however I've arrived at my image, I have to get it into the computer. So if I have drawn something with, whatever, watercolor, acrylic, or pens, or whatever, I need to scan it to get it into the computer. Once I've done that, I'm ready to start manipulating it. It can also be a photograph. It can be anything you want. Whatever it is, you've got to get it into digital form. And as you see here, open it up in Photoshop. So the first thing I'm going to do is come up here to Image Mode. Now, the default mode for most imagery is RGB, red, green, blue. That's because most imagery that we work with these days are viewed on screens, on computer screens. So it's best to have the default be in RGB mode because that's how we're going to be looking at the image. But that's not what we're going to do with the image. Now notice that right below the RGB is Cmyk. RGB and Cmyk are different color spaces. They have slightly different gamuts. Gamut being the breadth of colors that are available or obtainable with that system. So there are colors that can exist in RGB that cannot exist in Cmyk. RGB color space is slightly larger than Cmyk, and it's always going to be more vibrant because RGB is inherently a light-based surface that is producing that color. Whereas Cmyk, you're talking always about ink on a white piece of paper. So because it's not backlit, that piece of paper will never be quite as vibrant. Now even when we choose Cmyk color, what we see on our computer screen, it might change slightly, not much, but all it can do is try to give you an accurate preview of what it will look like once printed. So when I click on Cmyk, you might see a very slight shift in the image in terms of color. But if you do, it's only due to the computer trying to accurately preview what the difference will be. But if you see any difference at all, it's very minor. So the first thing we're going to do is make sure we're in Cmyk mode. That's fundamental, and you can't do what I'm about to show you unless you're in Cmyk mode. So make sure you're there. You also will want to be in 8 bits per channel. That is the default, so probably you won't have to change it. But if for whatever reason your image is 16 bits per channel or 32 bits per channel, switch it to 8 bits per channel. Next thing we're going to do is, again, image, and we're going to go down to image size. So right now this is just a random image I pulled up. Obviously, this was probably pulled off the internet somewhere. Who knows? It was just saved on the computer's desktop. But I'm not going to make a screen print that is 27 inches by 16 inches. Also, the default, for a lot of imagery is 72 pixels per inch. We'd like a higher resolution than that. So what I'm going to do is I'm going to unclick this box so that the link is here, shown right here, is not only linking width and height, but is also linked to the resolution. So the first thing I'm going to do is just change the 72 to 300. That makes the image automatically go to 6.587 by 4 inches. So at 300 pixels per inch, that would be the size of my image. Now, nothing changes because I had all those things linked. I'm not actually increasing or reducing the number of pixels in the image. So I'm not changing how much information was saved. All I did was change the ratio of pixels to inches. So by raising the number of pixels per inch and having it linked to the width and the height automatically had to go way down. At this point, if I think, well, I want an image that's 300 pixels per inch, but I actually want an image that's dimensionally slightly larger, I will click this again so that the link is no longer connected to the resolution. It's only connected for width and height. I could say, okay, now I want this, say, at 10 inches in height, and then because they're linked, then the width will be 6.073. Now when I click this, I'm actually adding pixels to the image, and so it's showing me a larger image, and then I can command it back down. So now I've got the size set at what I want, including the pixels per inch resolution. Now I want to think about, do I want to change the image at all in terms of how it looks? So any normal manipulation, if you want the colors to be more vibrant or increase contrast or whatever, now is the time you want to do any of that. This process that I'm going to show you here, it will change the image by the time you finish your screen print, and it's difficult to tell you briefly and verbally here all the ways that it will change. It will vary by the nature of the image. You know, if you have a black and white image and it's fairly low contrast, you might want to increase the contrast on what you see on the computer screen, because this process is going to lower the contrast a little bit. If you have a color image that has a lot of hue contrast, it is also probably going to increase the vibrancy of those colors in the nature of CMYK inks on the white paper. So you might say, well, I'm going to reduce the saturation of the image I see on the computer screen, anticipating that my colors are still going to be pretty vibrant by the time I screen print this. Now, if you're doing this for the first time, you know, a big part of this lesson is just going through this process and arriving at the finished screen print. Nothing can teach you more about beginning to understand how this works than doing that process. So I don't think that it's imperative that you now have a full understanding of how the image is going to change through the screen print process of CMYK. I think what's imperative is that you just go and you do it and you pay attention to how things do change as much as possible. So I'm going to call this ready to separate into the 4 channels. Now, coming over here to the channels palette, click right there, and you can see that I'm showing 5 different channels. Now, there's actually only 4 channels to this image. One channel that it's showing me here is all together. But if I start turning some of these off, so notice that the cyan is the only one with the eyeball clicked on. So that's all we're seeing right now. Now, when we only have one of the channels on, it's going to show it to us in grayscale. And the reason it does that is if it leaves it in cyan as a color, it's hard to discern certain portions. Like imagine trying to see this really light gray in here if it were showing it to us in cyan rather than gray. So it makes it a little bit easier to see. The programmers sort of assume that if you're only having one channel on at a time, that you are trying to determine quantity of information, quantity of value in any one spot, and that's just easier to see as a grayscale. As I click on 2, it defaults back to color. So now we're seeing what the image looks like with only the cyan and the magenta layers, or channels rather, turned on. And then if I click yellow, now it's showing me what the image is going to look like with just cyan, magenta, and yellow. And this image is a kind of a color drawing. So there's a lot of black line work. So in this particular image, it's going to rely a lot on the black layer. And that will vary depending on the nature of your image. If you are working with a photograph that was taken outdoors in daylight, you won't have a lot of black information, but this particular image does. So if I click that, it really beefs up the blacks, and of course it's normal again. Now if I turn off all these except for black, there you see it there. Now even here, clearly the black we're seeing right now in the lines is not as dark as when we have all of them. So the black that we're seeing here is very rich. When we just have the black, it seems like it's a dark gray, but it's not as rich a black. And the reason for that is that CMYK, the K stands for black. Really, it stands for key because it's going to be the final layer that you screen print, and that the key layer is generally printed in black. But the black that we're going to use, and the black that Photoshop is anticipating here, is a very, very transparent black, that if we printed that black on white paper by itself, would not be solid black. It would be a dark gray. And so that's really what we're seeing here. In CMYK printing, the highly transparent black is not meant to be the blackest black ever. What it's meant to do is tip the image over the edge. Keep in mind that cyan, magenta, and yellow are the pigmentary primaries where all three of those overlap. We are already going to get a kind of black. And that's why if we turn on all of these except the black, so here we only have cyan, magenta, yellow, we still have a pretty strong sense of the dark lines. They're not as black as they were originally, but they're clearly there. And so what we're seeing here is the computer's attempt to preview what the image will look like when only the cyan, magenta, and yellow layers are printed. So you can kind of see how the key black layer is meant to just tip it over the edge and really make those blacks rich. But the blacks that we're going to see in our final screen print are not going to rely exclusively on the black layer. They are going to rely on all layers adding up to create a strong, rich sense of dark. So that's an important thing to understand too. So you can sort of play around with your image and sort of start to see like what it's going to be like. And it's nice, you know, like with only the magenta, the image will look quite weird in certain ways when you're only looking at individual channels. Because again, you're seeing it as grayscale, and so like how dense this is here, that just means there's a lot of magenta that's going to be printed right in here. Now that's red, and we need both magenta and yellow to print red. So likewise, if we show the yellow is also really dense in that area. So anyway, we're not going to actually print from this. We're going to separate this digital file into 4 individual grayscale files. Each grayscale file is going to be 1 channel. So, and you only want to do this when all the other adjustments to the image are done. So what I just showed you about image mode, image size, or any other aspect of the image in terms of how it looks. that all has to be done before I do the next step. If all that's done and I'm ready for the next step, I go to this little thing right here, this little menu choice, and I come down here to split channels. Now what it's going to do is when I click that, suddenly I have 4 grayscale files instead of 1 color file. So my color file is gone. Now if I've saved it, great, I still have it, but it's not open. Instead, what I have is 4 grayscale files. And notice that that Photoshop automatically named each file appropriately. So this is the name of the file underscore cyan. This is the name of the file underscore magenta, name of the file underscore yellow, and the name of the file underscore black. So I now have 4 grayscale files that match perfectly in size, dimensions, and pixels, but they are all grayscale and reflect specifically the color channel that they came from. So this is going to allow me to make a film positive to expose to my screen for printing, in this case, the yellow onto my paper. Okay? Now the next thing that you have to understand is we're going to be using an Epson printer to make our film positives. If you've had Intro to Print with me or Brian, you may have used our laser printer, our HP 5500 laser printer, to make film positives from a digital file on the vellum or possibly on a special mylar for the laser printer. That works fairly well, but what I'm asking you to do for this project is to print your film positives on the Epson, which is the larger printer in the computer room of printmaking, because that's going to give you a better quality film positive. And by better quality, what I mean is the image area will be more opaque and the non-image area will be more transparent. With the vellum prints from the laser printer, there's always an issue that some light gets through your image area and that the vellum is not quite as transparent as we'd like it to be. It's a cheap option, and the Epson material will be a little bit more money, but it gives you a much better quality film positive. The Epson also can print much larger than the laser printer, so that's the other big advantage of the Epson, is we can deal with a larger print. Now this first round we're keeping things fairly small. However, once you learn this, if you want to do something similar, the Epson will allow you to go larger. The next thing you have to understand is that the Epson is a non-postscript printer. That's a technical fancy term, but essentially what that means is that by itself, the Epson does not have the built-in software to deal with halftones. So we have to introduce an additional piece of software to process this image, each of these 4 grayscales, into halftones. That's how Cmyk works mostly. Now we can do a traditional grid-based halftone, or we can also do a semi-random stochastic dot from like dither, and I can show you that. But one way or another, we have to take these gray pixels that we're seeing in any one of these 4 grayscales and translate those grays into dots so that the information can be held on your screen. Because again, screen printing is either or. When you expose the screen, either it's going to cure the emulsion or it's not, so that when you screen print, either the ink's going to move through the screen or it's not. There's no middle ground. In in whatever type of dot structure we choose to translate these 4 files, it is, in essence, a high contrast situation. That is to say, we don't have true grays. Instead, we have dots, and the gray is determined by the size of the dots and the density of the dots. And by density, I mean how close together those dots are. They can get so dense that they all merge, and you have an area that's just solid black, like parts of this yellow information here. But these lighter grays over here are going to have to get translated into a dot structure where the dots are not touching each other, where there will be small amounts of white paper showing between all the dots. And that is how it will achieve its grayness, or its tonality, that it's not solid. Of course, when I say gray, this is for the yellow. It's not actually going to be gray, it'll be yellow, but it'll be a tone of yellow, and whereas this will be solid yellow right there. So the outside software that we use on this computer to process the dots for us is this. It's called AccuRIP. RIP is a term used for various software packages that will process dots. So first I come up here and I think I click on this. Edit configuration, I want to choose. On this first page, we're up top where it says configure printer. I don't want to change anything on this. Leave this alone. I want to only go to configure halftone right here. And this is where we want to make whatever changes that we need to make. Now, the first thing let's talk about is the shape of the dot. You can choose round, diamond, line, ellipse, or FM. Let's ignore FM for a minute. You might think most halftones are just going to use round dots, and round dots generally will work very well. However, for screen printing, ellipse is a little bit better, particularly if you're trying to maximize detail in your image. And maximizing the detail is something I'm going to ask you to do in this project. So you're going to choose ellipse for this. However, there are times that you might want to choose line or round or even diamond. But if we choose ellipse, then that means the shape of each individual dot is slightly like an oval. That translates better to the screen than round does. And then the next thing we want to choose is right in here. So LPI is synonymous with DPI, and both refer to literally how many dots we will have in a linear inch in our image. There's a lot to cover about this stuff, but let me just say a few things. The number of dots per inch, or LPI, that you can have in your screen is determined significantly by the mesh count of your screen. And the mesh count is how many threads per inch you have on your fabric. Your screen that you're using for this class is 195 threads per inch. On that screen, I want you to go no higher than 35 LPI. You could go lower, but not higher. In order to achieve a higher dots per inch, or LPI, than 35, I would need a higher mesh count. Now, mesh for screens will vary widely. You can get as low as 40 threads per inch for really coarse, really thick ink applications, or you can get as high as in the 400s with very special fibers in different kinds of situations. But high thread count, high mesh screen printing requires a lot more technical knowledge and expertise and maintenance. So in terms of the balance of all the factors, the 195 threads per inch is a good place for you to start. 35 LPI or DPI is going to leave a discernible dot. That by discernible, what I mean is it will be clearly visible with your normal eye vision from a few feet away from the image. However, once you step back or blur your vision a little bit, you will no longer see the dot, and instead you will see the image. So for this project, I'd like you to stick at 35 LPI, and again, LPI is synonymous with DPI. Now the angle is important. It can vary, and it will need to vary at least somewhat. We're going to be using a halftone that is based on a grid. Once we print these out, you'll see how the dots go down in a grid. If I have multiple grid-based halftones printing on top of one another, one thing I have to really be concerned about is something called moiré. And moiré is spelled M-O-I-R-E, and it is an interference pattern that occurs when you overlay grid patterns, grid-based patterns. And if you take those two or more grid-based patterns that are overlaid and you start turning them, rotating them in relation to each other, you will see this interference pattern emerge, grow stronger, and then diminish and then disappear. So if we're going to print four halftone layers, one on top of the other, then we have to pay close attention to the angle of that grid of each individual layer. And this is where we're going to do that. So of my four layers, the cyan, magenta, yellow, and black, each is going to have their own angle. 45 is the angle for the black. So I could leave this just as it is, leave it on 45 and 35, and hit OK. And I'd just move this out of the way, and I'd come back to this. Now I don't want to print my yellow yet because I got the wrong angle set up. I would go to the black here, and I would go to print. Then I have two options for what printer to choose in the printer dialog box. Notice that both are Epson 4880. That's the printer. But one is AccuRIP to Epson 4880, and one is just the Epson by itself. Because I'm applying the halftone through this extra software package, I have to choose AccuRIP to Epson 4880, just like that. My preview here should appear correct. If it doesn't, something's wrong. I can check the print settings here, but and I might need, like right now, the paper size is 17 inches by 11 inches. The special film material that we use to print these on the Epson is on a roll. So that roll is 17 inches wide. So the fact that this is currently 17 inches by 11 inches means that it will accommodate an image that is up to not quite 11 inches in height, because I need a little extra space on either side of it. So it could be that I want to choose the 17 by 12. But be aware that the 17 is default, and that's the width of the material that comes off the roll. What I need to pay attention to is this number, the 12, which will accommodate the full height of the image. So if I hit save, notice that it slightly increased the white space on either side of the image. Like with all film positives for screen printing, I would not want the edge of the image to be right at the edge of the film material. I want the film material to go past the image. But that's even doubly true now, because if I scroll down, I'm going to need to add registration marks right here. And if this is not, if the little arrow is pointing to the right, then you have to click on it to open up these items. So I need registration marks, and notice that they just appeared right there. And I need labels and descriptions so that I know which film is for which color. And I should see those appear too, and I'm not. So let's come back here and let's actually choose 17 by 15. And there it is. So there is my label right there. Actually, the label is all I need. I don't actually need the description, but I need the label. And that's all it's going to tell me, is that this is the black. It's actually really easy to mix up your films. Sometimes it's even easy to accidentally burn the image reversed backwards. So that little bit of text right there, in this case the image has text in it, but yours might not. So that little bit of text right there is a nice reminder that, oh, I need to have the text right reading as I set it on the exposure unit and expose my screen. So we're going to click registration marks and labels, and we need to ensure that we're seeing all those things in the preview. Okay. Once that's done, we can hit print. So we hit that, and then we get this second dialog box, which is fine. That's normal. You just hit print again. Even though the image for the printer is wrong, that's your preview right there. Okay, you're going to hear the printer printing. The second video I'll be shooting with my phone, and you will see me sitting at the computer, and you'll see the Epson working. But before we jump to that second video, for getting ready to print now my yellow, I would need to go back to this, to the AccuRIP program, come back to here, edit configuration, configure halftone, because the 45-degree angle would be wrong for the yellow. So I'm just going to highlight that. Your yellow angle is 90. The 45 is only for the black. That's it. Nothing else. So you got to remember to come back here, choose the appropriate angle for the channel that you're about to print. So the 90 is for yellow. So then I would come back to this. I would choose the yellow, and then I would hit print, and I would do everything just the same. Now it's going to remember, it's going to have the same page size that it had before. So I'm going to go ahead and make that 17 by 15. I save. It's on just the Epson, so I need to switch to the AccuRIP. I need to scroll down. I need to check registration marks and labels. Ensure that all that's visible in the preview, and then I would hit print. Now I'm not actually going to print this right now, but I want to make sure that it's understood how you do it. So that would be how I would prep the yellow, and I would just hit print again. Then, as I wanted to print the magenta, I would again come back to the AccuRIP, edit configuration, configure halftone. So my angle for magenta is 161.6. 161.6, leaving it at 35 LPI. Then I would click OK, come back to the image, make sure I'm on the magenta. Then I would go print AccuRIP. 17 by 15 was already on that. Scroll down. I need registration marks and I need labels. I visually ensure that it's all there, and I hit print. I'm going to go ahead and print this one, and I'll do the yellow and the black in the next video, but I'll print the magenta now. So again, you'll hear the Epson in the background here printing. And then as I go to the cyan to do that, the cyan angle is 108.4. So I go back to the AccuRIP. .4. Click OK. Now I'm on the cyan. So then I would print. Make sure it's on the AccuRIP. 17 by 15. Scroll down. Add registration marks, labels. Make sure I see all that in the preview. And then I would hit print. Now you'll see me do this again in the second video, but I wanted to make sure that you saw in this video all of those angles that you need. To recap them, the angle for black is 45. The angle for yellow is 90. The angle for magenta is 161.6. And the angle for cyan is 108.4.